Swayam Prabha. Digital India. Educated India.
Dear viewers, from this session onwards, I would like now to discuss some applications using advanced techniques of surveying. The basic idea is to provide an overview regarding the use of these techniques in generating theme-based maps so that proper decision making can be undertaken. So, first of all, let us look at how drought information and mapping can be done. Drought is a multidisciplinary and multifaceted complex phenomena. The spatial prediction of drought and its susceptibility is a difficult task. In this particular illustration, the drought prone areas of India is shown. One can see that the major part of India is prone to drought phenomena, and thus this is a very critical natural hazard which takes place, and it affects a vast majority of the population of the country. Naturally, its direct impact is on the crop production, which is one of the major factors which could lead to economic imbalance in the country in any given year. So, first of all, let us look at the classification of droughts. Droughts can be classified as meteorological droughts, hydrological droughts, agricultural droughts, socio-economical droughts. Meteorological drought. It is defined as the degree of dryness in comparison to normal or average amount and the duration of the dry period. It considers the specific atmospheric conditions that results in deficiencies. It can be classified as moderate drought if the rainfall deficit is between 26 to 50% and severe drought when it exceeds 50%. Next is hydrological drought. It occurs if meteorological drought conditions is prolonged with marked depletion of water surface. It leads to the drying up of the reservoirs, lakes, streams, rivers and lowering of the groundwater table, which serves as an indicator. The soil water deficit is an indicator of the hydrological drought as it governs the runoff in the streams. For developing the hydrological drought indices, the reduction in stream flow, groundwater and surface water can be used. Next type of drought is agricultural drought. It can be defined as the lack or shortage of soil moisture in the root zone due to rainfall deficiencies. It takes into account the physical and the biological aspects of the plants and the interaction within the soil plant atmosphere. It fails to support healthy crops during the crop growing season, leading to water stress, wilted crops and damage and failure of the crops. It does not necessarily coincide with the period of meteorological drought and hydrological drought. The fourth type of drought is socio-economic drought. It is defined as the supply and demand of water, forage, fruit, grains and hydroelectric power. Its impact is mainly associated with public safety, health, conflict with water users, reduced quality of life and inequalities in the distribution of drought relief. So, let us look at what are the parameters which affect drought. These are rainfall, ambient air temperature, relative humidity, evaporation and evapotranspiration, soil and soil moisture, surface water bodies, groundwater, land use, land cover and agricultural crops. In order to analyze for droughts, we need to have some criteria. These criteria are with the help of certain indices which can be defined, so that they take into consideration the various aspects of the drought conditions. Since the three major drought conditions have been defined to be meteorological, hydrological and agricultural, so the criteria for drought analysis have also been associated to these conditions, and thus they are namely meteorological indices, hydrological indices and agricultural indices. So, let us look at what are the meteorological indices which are available. First is normalized deviation, second is dryness index, De Martini index, arid anomaly index, Balmy and Mooley index and Palmer drought severity index. Out of these indexes, probably the indices number 1 and the last indices, that is the Palmer drought severity index, are very commonly used for drought analysis due to the simplicity and the incorporation of information which is there. The next is hydrological indices, and in this we have two indices which are there: surface water supply indices, in short SWI, and reclamation drought index RDI. The third type of indices are the agricultural indices, and these could be vegetation indices or normalized difference vegetation index. Having had a look at the analysis and its criteria, how do we manage a drought? The success of drought management largely depends on the availability, dissemination and effective use of information. Drought management plans will be really effective if there is a policy on which it builds. Drought management plans are good only if they are implementable with clear cut roles and responsibility defined. Such plans should be revised and updated regularly. One important aspect is the timely recognition of the recurrence of drought and identifying its severity. So, what are the major activities which need to be undertaken for drought management? First of all, we should have a pre-drought planning, preparedness, monitoring, including enhancing relief management capabilities, which starts year before the event occurs. Prediction and early warning system shortly before the event, and drought assessment and relief management starts shortly after the event has started. Now, drought management strategies could be of two types. First is short term strategy. Well, this entails monitoring and assessment of drought situation by the way of continuous observation of water levels in major reservoirs, groundwater level, rainfall and crop status, economic condition of the rain fed farming, which will be reflected in the procurement and investment likely be to made during the crop growing seasons. Subsidized transport cost of hauling of feed and fodder, and setting up of animal rescue campuses in a drought prone area. Well, the long term strategies could include increasing availability of good quality of water in drought prone areas, ensuring availability of quality fodder and livestock strategy, upgradation and fine tuning of crops or crop system production technology, specifically targeting drought prone areas, exploiting underexploited or underutilized plant resources, and creation of alternate income and employment generating opportunities in the drought prone area. Having had a look at the management aspects then and the strategies, then we now look at the mitigation of drought. Drought mitigation can be successful only when detailed knowledge is obtained about the expected frequency, character and magnitude of such events. To mitigate droughts in the area, suitable drought resistant crop types and soil and water conservation measures are suggested by the integrated use of remote sensing and GIS techniques. The success rate of measures suggested to combat drought in the area is a matter of time. A good mitigation strategy should involve developing a good weather forecasting system with the help of remote sensing and GIS, contingent crop planning and farming systems to cope up with drought, desilting of irrigation tanks to be intensified, percolation tanks, that is with the help of check dams across streams and water courses that are quite effective for artificial recharge of groundwater reservoirs, promoting dry land horticulture, agroforestry and tree planting, establishing and strengthening drought mitigation fund with credit recycling and flexibility of loan recovery, strengthening farmers advisory services and increasing accountability in drought mitigation programs. Now, we go on to the use of remote sensing and GIS for drought assessment. Here, I am going to take up a small case study which has been carried out for Tumkur district, Gubbi Taluk in Tumkur district in Karnataka. We all are aware that Karnataka is one state which is facing drought for years together, and probably the last 50 years of records show that out of this probably 70 to 75% of the time the state is under severe or moderate drought conditions. So, in order to make an assessment of the same, a well structured methodology has to be adopted. Well, in this case study, 3 basic levels of analysis have been adopted. First, considering the rainfall data, then use of remote sensing data and meteorological data. With the help of rainfall data, drought classes can be identified on the basis of rainfall departure from the normal as defined by the Indian Meteorological Department. Well, IMD as a matter of fact has given certain ranges of departure. If the departure is 0%, then there is no drought. If it is less than 25%, then it is a mild drought. If it is less than or equal to 50%, then it is a moderate drought, and if it is greater than 50%, then it is severe droughts. And these have been classified as M0, M1, M2, M3 respectively. Similarly, when we are using remote sensing data, using remote sensing analysis techniques such as finding out the NDVI and other indices, agricultural drought classes can be identified using a drought severity index, or in short DSI, and under this, if the value of DSI varies between 0.6 to 1, it is no drought condition. If it varies from 0.2 to 0.6, then it is mild. If it is varying from 0.2 to minus 0.2, then the drought condition is moderate. Between minus 0.2 to minus 0.6, it is severe drought condition, and if the value is between minus 6 to plus minus 1, then it is extreme drought conditions. Similarly, we can use remote sensing data and meteorological data to identify drought classes by integrating land use, meteorological and other data using GIS technique. Having looked at the methodology to be adopted to identify drought, let us look at what type of data is required. As I have already said in the initial stages that this is a multifaceted, multidisciplinary aspect. So, here probably we will find that the data that is required comes from various sectors. First is we need to have the information regarding the ground. So, we need to have the topographical maps. Well, topographical maps brought from Survey of India located at Dehradun by paying a nominal price for the paper copy maps. However, the present day scenario is that these maps are all being converted into digital maps, and thus the user can directly use this information for creating the required data GIS databases. Next is the revenue map, that is the type of money generation in a region. Well, this can be available from the directorates of state land and survey settlement departments. Third data set is naturally the remote sensing data set. This is going to provide us the multi-date information which may be required to make an assessment of the drought. In India, the nodal agency to provide satellite data is the National Remote Sensing Agency located at Hyderabad. Then we may need agroclimatic maps, which could be available from the land use, state land use boards, climatic data, which could be obtained from regional meteorological centers or from IMD at New Delhi. Then we may require the village wise statistics of a particular district, and this could be available from the regional director of the Census of India, or we can get it from the Director General of the Census of India. Then rainfall data, this also can be had from IMD or it can be brought from other agencies. Then the rainfall map, this map could be maintained by various agencies who may be involved. One of them could be the drought monitoring cell, or one can go to IMD and also get the rainfall map for different times. Then water surface water tanks, well, these could be obtained from the minor irrigation departments, and village details can be had from the Jilla Parishad of the concerned area. So, now let us look at the drought assessment by rainfall approach. Here our computation would be based on the departure of the rain from the normal conditions, and this could be obtained by the relationship as shown here, wherein we compute the annual rainfall minus the normal rainfall divided by the normal rainfall multiplied by 100 to express the departure of rainfall from the normal. The normal rainfall is nothing but the long term average, and these values are available from the IMD. So, for each year the rainfall which has occurred, we can make an assessment as to what is the departure of the rainfall which is there, and on the basis of this the assessment of different regions within the study area can be carried out, wherein we can say as to what is the rainfall for given areas. Here the rainfall assessment or information is available as per rain gauge stations. So, based on the rain gauge station locations at different points, the normal rainfall condition has been derived. So, for the 36 years of data is available, and based on that the normal or the LTA value has been computed, and based on this the probability of drought occurrence under each rainfall stations has been computed, and what it has been found that based on the information which is available, drought no drought condition has existed for about 52%, that is for 19 years, one particular rain station has experienced no drought condition, whereas in other rainfall stations we can find that the amount or the distribution of different types of drought conditions or classes have been found out, and what we find is that on an average about 47% of the times there is no drought condition. However, the extreme drought, that is the severe drought condition, only has occurred for 10% of the time, whereas moderate drought has occurred for nearly about 15% of the times which is there. Well, this information is very good, as it tells us the status of the rainfall, that is the meteorological based drought conditions, how they have affected the region, because it is very necessary to ascertain as to which has been the causative factor, whether it is rainfall, whether it is the meteorological conditions, or it is the hydrological conditions, or it is the agricultural conditions which have brought about the drought in a particular region. So, based on this, now one can make an assessment as to which were the years for which the drought conditions, various categories of drought can be identified, and thus the analysis has been carried out for nearly 51 years to identify the type of droughts which have occurred under different rain gauge stations. This particular slide, as a matter of fact, is a graphical representation of the earlier information that has been obtained. Having had a look at this particular analysis procedure, what we can find is that every alternate year, on an average, the area is subjected to drought conditions varying from mild to severe. Now, let us go on to the next approach, that is the Drought Severity Index approach, or the DSI approach. The DSI approach, as a matter of fact, is a approach for assessing the agricultural drought, and here primarily remote sensing based inputs are going to be used to make an assessment of the DSI. For this, the remote sensing data would be subjected to various data processing techniques, so that land use land cover maps can be generated, and based on the land use land cover map, the drought severity index can be found out. Having found out the drought severity map and overlaying this information over the village map in a GIS environment, it is then possible to identify village wise drought severity map. Having had a look at the methodology right at the starting, the viewer should be able to appreciate one simple aspect, and that is that instead of looking at regional status of the drought, this particular approach allows us to make an assessment on a village to village basis. That is, this is a detailed process of identifying the droughts, which are the villages which have been subjected to severe conditions and which are been subjected to different levels of severity in terms of drought. So, based on this, we have undertaken the study for finding out the agricultural drought during the year 1996 to 2001. Based DSI can be found out by the relationship which is very similar to NDVI, except that here instead of taking the satellite data, we try to find out what is the crop area and the barren area, and then find out the compendo dividendo relationship of the same. All right. And thus, this is a index which takes into condition that how much barren area is there in comparison to the crop area, and as this will If barren area increases drastically, the value of DSI will approach towards negative values, and that will help us in identifying where the crops have failed, and thus we can say that these are the areas where the agricultural droughts have occurred. So, for this, certain time series satellite data for the study area have been selected. These are primarily pre-monsoon and post-monsoon data sets which have been taken. For example, October 1996, March 1997, March 1999, September 1999, March 2001, October 2001. So, these are the pre and the post monsoon seasons, on the basis of which we are now going to proceed to, first of all, generation of the land use and land cover map using remotely sensed data. In this particular study, digital data has been acquired, and from these digital data, on the basis of the information available from Survey of India, the images have been first georeferenced to the ground, so that all geometric errors are minimized. Based on the ancillary data which may have been collected from various offices or by field visit, we undertake the selection of the training data of different informations which are present. Based on this information, we compute the training data statistics and perform the supervised classification using maximum likelihood classifier. In order to have confidence in the assessment which has been done for land use and land cover using remote sensing, we need to do the accuracy assessment. Here the criteria was kept as 85%. So, on the basis of the approach as discussed just now, the land use land cover maps of different time frames are shown in these two slides, which highlight the different types of information which is available here. The information which may be of interest could be the location of the surface water bodies. What we can make a direct assessment is how the water bodies have changed with time, because this would be an indicator of the availability of water not only on the surface, but also may provide indirect indicators to the availability of water within the ground, the depth to which the water may be available. So, based on the assessment of the cropped area and the barren area for different times for which the satellite data is available, village wise agricultural drought assessment for the year 1996 to 2001 has been carried out. Well, the DSI values have been converted into raster maps, and then they have been superimposed over the taluk or the village map which has been made available from the Jilla Parishads, and different category of droughts have been identified. It is the viewer may be able to now appreciate the advantage of using such advanced surveying techniques, because now he has a clear cut idea as to which are the villages which have been subjected to severe drought conditions and which are the villages which are under no drought condition. Here we have used the pink color to alarm the viewer that these are the areas which are subjected to drought condition, and wherever the green color has been shown, it shows that these are the areas where there is no drought. And what we can see is that the drought conditions over a period of time between October 1996 and 1997, there is a significant increase in the extreme conditions of drought which is occurring there. Well, this sort of information will not be available at a very quick stage, because ground based techniques may not, by the time we compile the information, probably the assessment may have no value. So, use of remote sensing provides us that particular advantage. So, similarly, the same type of exercise has been performed for the year 1999. All right. Here the viewer may be able to appreciate that in some portion the drought severity from extreme conditions have reduced, that is, there is an improvement in the mitigation measures which have been implemented in the area. Similarly, for 2001 the assessment has been made, and what we find is that in this particular year, after the monsoon is over, the severity, extreme severity conditions, specifically in the top part of the taluk, has undergone a significant increase in the number of villages which are there, and thereby it shows that in the northern part of the taluk, in all the 3 years, the conditions of drought are persisting, and thus this type of information, when provided to the administration or to the planners or decision making, they know which are the areas wherein concerted effort of providing relief or adopting measures, so that the drought can be removed or it could be reduced in the particular area. Our third approach is using remote sensing and GIS technique. For this, we are now going to use lot of other ancillary information as have been defined. Well, these data sets could be either in tabular form or they could be in map form in hard copy. So, they need to be converted into digital data. So, from these digital data, we may have different types of information which could be correlated to the meteorological conditions, or it could be related to the agro socio-economic conditions which are there, or it could be related to the land use. Having acquired this information, naturally this data set has to be created within a GIS framework, so that one can have a GIS database through which data manipulation and analysis for various aspects can be undertaken. In order to do the analysis, we need to also identify one another important aspect, and that is what is the weightage or importance, you can say, in terms of the variables which have been taken into consideration. So, one has to provide the rankings, and similarly ratings also have to be provided, which can be then integrated in a GIS to create drought severity maps. Over these drought severity maps, we superimpose the village map. So, we can have the village wise drought severity maps. So, based on the methodology that we have seen, we have now all these information first of all has to be converted into a digital form. As you may recall, all GIS database creation probably is one of the major tasks in GIS based analysis. It takes about 2/3 to 70% of the project time and resources to create a GIS database. So, here the user should now be able to appreciate the type of information which may have to be converted into digital levels. First is, we need to identify what is the administrative boundary or the extent of the study which is there. So, since we were working for a taluk area, so we have the taluk administration boundaries which have been converted into digital form by digitizing the administrative boundaries. Followed by this, the village boundary maps have been digitized, and along with them the village IDs also have been stored. so that a distinct location to each area can be given. Similarly, the annual rainfall map, since we are using post and pre monsoon, so rainfall during the September months also have been taken, the evaporation which is taking place, the annual evapotranspiration which is there, the maximum temperature, April month temperature, then evaporation during the month of April, relative humidity, live storage, water tank, land capability, irrigable land, tank irrigable areas, then cultivator areas, that is how many cultivators are there in each of the villages, that has been identified, agricultural labors which are there, these are all socio-economic data, basically demographic information which is there. Then we have village amenities layers, the population layers, and having converted all these information which could have been either in the form of a table or in the form of a map, they have all been converted into a digital map and shown to you, so that you can appreciate the information conversion which takes place from actual data to a GIS data set. Having done this, our next task is to identify what is the weightage that we need to provide, and based on this we may have different levels of importance, and these could be given weights from 1 to 9. 1 means equal importance and 9 means extreme importance, and using this concept, pairwise comparison matrices and consistency index and consistency ratios have been worked out. Based on this, the drought parameters have been identified. There are 17 such drought parameters which have been taken into consideration, and we have already seen the creation of these layers in the previous slides which is there, and based on this we now go on to provide the ranking and the ratings of the various drought parameters, that is what is the ranking and what is the rating which is there. So, for example, for rainfall, annual rainfall, a ranking of 0.165 has been carried out. Well, this ranking has been performed or obtained by using normalized pairwise comparison matrices, which is also known as the Satie's method of ranking and rating. So, based on this particular approach, different parameters have been given ranking. For example, maximum temperature has been given 0, all right, whereas some of the parameters are having very low ranking which is there, but the net sum of all these rankings which have been given, this is equal to 1. Now, within each ranking ratings also have been provided, that is we need to segregate or classify or group the information into different levels, and based on that ratings of to level of 5 has been uniformly adopted for all the parameters which contribute towards the drought, and based on this information the computations of the drought severity index have been carried out, and what we find is that using this index we can now find out what is the drought severity map which is there. For simplicity in understanding, green has been adopted for those conditions where we are having no drought conditions. Orange means, as in a traffic light, orange means that this is an alarm, that is you need to be alert now. So, those areas which are having moderate drought conditions have been given a orange color, and those areas where there is the danger of extreme drought conditions, they have been given a red color. Fortunately, for the years of analysis which has been carried out, what we find is that extreme drought conditions are not present. However, when we try to compare our analysis procedures with respect to rainfall deviation methods, it says that about 10% of the times in the last 50 years extreme drought conditions have occurred. But what we find is that within the period of 1996 to 2001, probably the extreme drought conditions have not existed in this particular region. However, what we may find is that large areas are under moderate drought conditions, and this needs to be looked into by the administrators, decision makers and planners as to how we can elevate the problem of drought in this particular region. First is rainfall based analysis is not adequate for drought assessment. It is a post scenario analysis. The change in land use land cover is consistent to the lack of rainfall, and it has been observed that the area under high drought probability does not coincide with the classification of the drought. Actual drought conditions, that is severity in a region, cannot be revealed by IMD method, since it does not take into account the terrain characteristics, spatial distribution of rain gauges and worthiness of the rainfall data. Drought severity index has utilized derived information from remote sensing data. It provides a better assessment of the scenario on temporal basis, since it takes into account the land use and land cover aspect only. DSI does enable to identify agricultural drought at the smallest administrative land parcel, that is the village level. In addition, it depicts the intensity of the agricultural drought severity. It does not take into account the meteorological parameters for its formulation. DSI relationship is an indicative of the loss of productive vegetation. It will help the administrators to identify regions as per intensity of drought, to plan and undertake drought relief and mitigation measures. GIS techniques account for all possible parameters which may trigger the mechanism of drought. This study has identified drought at the smallest administrative level, at that is the village level. GIS technique provides an insight to drought as per the existing conditions. It provides results at a near real time basis, and hence it may be possible to halve the growth of drought, if not reverse it. This study has aptly demonstrated the utility of the modern methods that employ both remotely sensed data and GIS to identify and assess drought conditions. Also, it has resulted in arriving at a properly timely solution for drought management and drought mitigation measures. In my next session, I would like to take up another application on infrastructure planning in a region using advanced techniques of surveying. Thank you.